Asif, hello Asif, cycles a distance of 105 kilometers. It's a serious man in terms of cycling. That is 100, and I'm assuming it's a man. My apologies if it's not. My apologies, Asif. 105 kilometers. Damn, son. On the first part of his journey, he cycles 60 kilometers in 2 hours. 2 hours and 24 minutes. And on the second part of his journey, he cycles 45 kilometers at 20 kilometers per hour. That, well, to be fair, now he could have taken a break of a couple of weeks, months, years. We don't even know. What we want to find out is, well, that would be a bit strange, but what we want to find out is the average speed. So it's the average speed that we're looking for. And in addition, we've got some data here. We've got 60 kilometers in 2 hours for our first part of our journey. And for the second one, we've got 45 kilometers in 20 kilometers an hour. That's pretty quick as well for a bike, considering. Right, that's this guy. Finally, the final journey, the total journey is 105 kilometers. So we were aware of that. Now, first of all, let's just state to the examiner what we know. What is it that we know? We know what we have knowledge of is the speed is equal to distance divided by time. But we don't want speed, we want average speed. And it might be worth recalling that average speed is sum of the distance divided by sum of the time. And that is the sum is in SUM, of course, as stated on this in this situation. The sum of the distance is 105 kilometers, it's 60 kilometers plus 45 kilometers, and so we can just leave it like that. That bit's already been calculated. The sum of the time, however, we're not quite sure. I don't believe we have that information. We've got the 2 hours and 24 minutes, but we don't seem to have the time for the second part of the journey. And that's something that we can calculate quite comfortably, I believe, if we go through this. So I'm going to state this. I've got, okay, right. So the sum of the time, the average speed is 60 kilometers plus 45 kilometers. That's the sum of the distance. Now, the sum of the time is 2 hours and 24 minutes as the left side of the denominator. And we don't know the second part. So I'm just going to call it time unknown. Anyway, now, one of the issues that we have is this 2 hours and 24 minutes are 2 different units. And I don't judge it's advantageous to have this. It will make things complicated. It will not allow for the calculation in the end anyway. So therefore, we need to make this 2 hours and 24 minutes. Either all of this needs to be minutes or all of this needs to be hours. So one of the things I'm going to recognize is that we know that there's 60 minutes in 1 hour. So I can find out the relationship of what 24 minutes is in terms of an hour. 24 minutes in terms of an hour. I can do that by simply just going, well, 24 minutes. If I wanted to turn it into hours, I could go 24 minutes divided by 60 will give me 0.4 of an hour. And that, again, that makes sense. It's about 0.4, meaning that if it was 1, it would be exactly 1 hour. If it was 0.5, it would be exactly 30 minutes. And so 0.5 being 30 minutes, this is 24 minutes. That seems legit to me. 24 minutes out of 60 minutes, 0.4 of an hour. So I now can change this 2 hours and 24 minutes to something that literally says 2 hours plus 0.4 hours. And I've sorted out the issue with this unit here. Okay, so now I can then move on to this next part, which is to try and find out the unknown time. But before I do that, I'm just going to clean this up. I said, therefore, 2 hours and 24 minutes is equal to 2 plus 0.4, which is 2.4 hours. And the average speed is equal to 60 kilometers plus 40 kilometers. That's the sum of the distance divided by 2 hours and 24 minutes, which I now am going to call forever. I'm now going to call instead 2.4 hours plus our unknown time. So how do we calculate the unknown time? At the moment we're at this situation, it's not too bad. We're just missing this time. Now I'm going to do a little bit of an algebra for this. It's relatively simple. If you bear with me for one moment, we should be able to get through this quite comfortably. If speed is equal to distance divided by time, and what I'm going to do is I'm going to multiply both sides by time. So I'm going to times by time on this side, so it'll be like times by time on here. And of course I'm going to times by time on this side, so because otherwise the equal sign will become void, it would not be equal on both sides. So I'll times by time on the left hand side as well. So by timesing by time on both sides, I have the advantage of cancelling these two out. So I have this situation where I can say this will cancel with this. This is done a little bit better by me underneath in terms of speed times time. You see me multiply by time on the left and multiply by time on the right. And of course, these things here, these variables, this variable of times cancel, leaving simply distance. So I now have speed times time is distance. This is a formula that's worth learning just as much as speed equals distance divided by time. That is to say, if you know speed is distance divided by time, you can multiply both sides by time and know that speed times time is distance. So if they gave us speed and time, I'd be able to work out distance, but that's not what they got. Just as a little point in terms of an example, this we can know to be true by analyzing the units, which is called dimensional analysis. If speed is in kilometers an hour, and we are aware of this, speed is in kilometers an hour, and time is in hours, then you can simply do, again, quite basic algebra to work this out. The hours will cancel. That hour there cancels with that hour there, because one's the numerator, one's the denominator, and therefore you're only left with kilometers, which is the unit for distance. So it is definitely true, that concept there. Speed times time is distance. Okay, next stage. Thanks for bearing with me on this one. We're nearly there. All we now need to do is we need to get the equation for time. And so what I want to do is I need to get rid of this speed. There is the time I want. I need to get rid of speed. So how do I get rid of multiply by speed? I divide both sides by speed. So here I divide both sides by speed. Speed's been divided on the left-hand side, 1 over speed, and 1 over speed on the right. Finally, then, these cancel. That speed cancels with this one, leaving me with an equation that's just time is distance divided by speed. And these are the 3 main equations necessary for you to do these topics in GCSE. We've got equation 1, which is relatively intrinsic because speed is in kilometers per hour, meters per second, miles per hour. Speed is distance divided by time. Equation 2, speed times time is distance. And equation 3, time is distance divided by speed. And the way in which you can get to those, remember this one, and then simply just do some basic multiplication algebra and division in order to get these equations. This is the one I want, and from here I can pretty much finish off. I have the time unknown is the distance divided by speed. Well, what is the distance? If you look at the original question, the distance we have, a little bit of a lag there, this is 45 kilometers. 45 kilometers and 20 kilometers per hour. So I can just implement that information in now that I have that. I can simply say 45 kilometers divided by speed. The speed is 20 kilometers an hour. So I can simplify this down saying the time unknown is 45 over 20. 45 over 20. And therefore we have it. We've made it. Thank you for concentrating on that time. If you did, if you did not, my bad. And in these circumstances, we can conclude with the average speed is 60 kilometers plus 45 kilometers, the sum of the distance divided by the sum of the time, which was 2.4 hours, plus the 45 over 20. That is the time for the second part of the journey, and thus we've also known that this adds up to 105. This was also given in the question. And if you type this in your calculator or you do a little bit of numeracy, you'll find that you get 22.6 to 3 significant figures for that question.